Well, hi guys, can you hear me? Hi Mike. Hi Jeff. Let me know if you can hear me. Unmute your mic for a minute if you need to. Okay, I'm getting sound now. I think I can hear you guys.
Do you hear me now, Bill?
I do. Hi Mike.
Hello, Bill.
Good to see you.
In the background?
Yeah.
Well, I thought I heard her.
Yeah, she's in the other room. Hi Rita.
That's
Say
all
hi
right.
to Mike.
Hi, Mike. Hello, hello.
She's watching Star Trek.
I was gonna mute my microphone because my son's in the room watching television. I didn't want it to confuse.
Oh. Well, we had 3 of these. This is the 3rd one tonight, but the second one was interrupted because I wanted to attend a similar session that McDonald Observatory in Texas was hosting. And so I left the meeting to do that, and actually I patched that through here for the first half hour, and then I went ahead and left. So, but we're back. We're back. How are you guys?
Fine, thank you.
Good, good. I'm really tired of being stuck at home. Really, and it's a clear night. I would actually be stargazing for real tonight if it wasn't for the quarantine. But the conservation areas are closed. They really don't want you congregating, so thought it'd be better to cancel and just do a virtual star party just in case somebody was interested in still getting together. So as you can see, I've got the software set to the real time. It's showing 22:03, which is 10:03 p.m. I've got it set for Danville Conservation Area. So this is what we would see tonight. And it is completely dark. When we first started, it was twilight. So we were looking at Venus and we were looking at double stars, but now we can basically go for anything. And I'm gonna veer off the Messier list and try to find some objects on the Royal Astronomical Society of Canada's list for the month of April. So the first 5 of them are all in Ursa Major. So let's move toward the north. Let's spin our Dobsonian scope around here toward the north and head up towards the Big Dipper. There we go. There's Ursa Major. And what they have on their list, the first one is a 10th magnitude galaxy, NGC 3079. So we're going to use this as a star chart. We're going to have the star chart show it to us here. So this is a 10.8 magnitude galaxy in the constellation Ursa Major. So let's take a look at it through the finder and see if we can find anything. Still pretty faint. I'm not really seeing much there, but at nearly 11th magnitude, I wouldn't be surprised. So let's see if we see any hint of it through a low power eyepiece. I don't see anything. And it's obviously in the catalog because it's showing up here on the list. That is just, so what's happening here is the software showing me that I couldn't see it even from Danville. It is just too faint and it has too low of surface brightness. So that would be a big disappointment. But I would at least say I tried to find it. It's just too faint. So let's see. Let's go back out to a naked eye field. And let's see if we can find one that's a little brighter than that. Here's a magnitude 9 galaxy in Ursa Major, NGC 3184. Too far from it. Yeah, this is bright enough to show up from Danville. Let's go with our finder scope. Gives me about a 6-degree field of view. So the star chart's showing me its location with that little red oval, even though I'm not actually seeing it yet. So let's try an eyepiece. So I don't see it here. I don't know if that means it's too faint or if there's just no image of it in the software, and that could very well be. So at least we know where it is in the sky. These are very faint galaxies. Oops, too far. Okay. Let's go back to naked eye field. Yeah, it looks like we're pretty high up here. Yeah, we're almost at the zenith here. I've got my scope pointed almost straight up. That would be difficult. Let's go down a little bit here. There we go. Okay, so let's see if we can find a spiral galaxy on Patrick Caldwell's list. Caldwell 40. It's also cataloged at 10th magnitude. We'll see if we have any better luck with it. It's NGC 3626. So this is a galaxy. It's a spiral galaxy in the constellation Leo. And it looks like through a medium power eyepiece, it almost looks stellar. It has a very small diameter. Its listed size is only 2 arc minutes by 1 arc minute. So it's not really much bigger in size than oh boy, what's only 1 arc minute across? Venus, maybe as big as it gets. Venus gets to be just under 1 arc minute across. So this galaxy doesn't appear to be much bigger than a planet through the eyepiece. Okay, let's go back out to naked eye view. Hey, John, did you do the McDonald Observatory?
I did.
I did too. In fact, I had to leave early to come and do this. I felt bad.
So did you note my comments about lighting?
Yes, I did.
Okay.
Who wants to see me anyway? Here. There you go. Is that better? But now it's blinding me in the face. There we go. Okay. Okay, what about, this is a time of year that I would look for the ghost of Jupiter. It's actually a Caldwell object, and it has an NGC number. It's NGC 3242, and it's in the constellation Hydra, so this is the time of year for it. So Hydra is right over here in the southeast. Yeah, just a little bit south-southeast, actually. So let's see if we can get let's see how this software simulates the ghost of Jupiter. I've never done that before. Let's have a look at that. I would actually go for that tonight. 3242. No, I wasn't too far off. So I was going by this middle star here in Hydra near Alphard. So let's see if it's shown here. Let's look through the finder scope. So let's get a 6-degree field of view. And the Ghost of Jupiter is a planetary nebula, so it's going to be real teeny tiny. Through a finder, it's going to look stellar, like a faint star. So you just want to locate it with the finder and then throw in a medium power eyepiece to see anything. So to me, it still just looks like a star. I'm not really seeing anything exciting. Through the telescope, it really does look like Jupiter, but it looks like a faint translucent version of Jupiter. And Jupiter has an apparent size through the telescope about the same as Venus, about an arc-minute across. And this is listed as only about half an arc-minute across. So it's listed a little smaller, about half the size that the planet Jupiter appears in your telescope. So if you're out in the spring, take a look at it. It's worth seeing. Software doesn't do it justice. Okay, requests, suggestions, discussion, anything?
Yeah, how about a live view from your telescope?
Okay, hold on. Let me go get it set up. I'll be back in about an hour. Hey, Jim, I did go outside and look for those satellites.
Oh, which ones?
The Skylink ones.
Oh, yeah, I didn't see those.
I didn't see them. The email said they were going to be up sometime between 8 and 9.
Oh, okay. Nice, John.
I was doing this session from 8 to 8:40, so I went out about 8:45 and looked up I spent about 10 minutes outside. And they're supposed to be first magnitude, so easy to see.
Oh,
I
yeah.
didn't see them. And I looked. I went all up and down the back and around the side of the house and tried to get the trees out of the way. And it is a clear night, though. It is nice outside.
Yeah, temporarily.
Yeah.
It'll cloud up in another hour or so.
So it wouldn't have been worth the drive? Is that what you're saying?
I didn't know. I just looked at the weather report at my end. It looks like it's going to be cloudy later.
Well, if it would have stayed clear until midnight, that would have still been worth it for me.
Oh, probably, yeah.
Okay, there's a couple of Messier objects I've missed on my April list. The Owl Nebula in Leo, M105. So let's swing our telescope back up toward Leo. Get a little help here, shall we? Okay, now M105 is where in Leo? Let's see. Get my star charts out. That's part of the Leo triplet, and I don't think this is it either. Mark's got all these memorized, so we need Mark here. I don't have them memorized. I don't have some of them, not all of them. And that's the one I was going to pick next, wouldn't you know? Okay, M105. Let's look through the finder. Man, it looks like if we had a view through our finder, we'd have some bonus objects to see here. There's a lot of galaxies in this area. Let's look through a low power eyepiece. A little bit less than 1 degree of a field of view. Oh, that's sweet. And you know, I've seen M105 before, and I do not remember getting 3 galaxies in the field of view. Maybe the other 2 are too faint. The 105 is listed at magnitude 9. See, and this NGC is magnitude 10, and this one's magnitude 12. So maybe I've seen these 2 and not necessarily the 3rd one. It has a size of 5 arc minutes across, so it's pretty good size.
12th magnitude galaxy is pretty tough to pick up in an 8-inch.
Yeah, that's probably what it is, John. My scope's probably too small. I've had the chance to look through some larger ones. Who is it that brings a real big one out? Is it Jim Twellman?
I think so.
He gave me a view of the Veil Nebula one summer, and it really spoiled me. I went out and bought an O3 filter after that and used it on my scope, and it was kind of a waste of $100 because it doesn't really work that well with an 8-inch scope. You need more aperture for that.
Well, think about it. It's an O3 is a cutoff filter. So what you're doing is you're cutting down the amount of light coming through the filter. And if your aperture isn't big enough to start with, the filter is not going to help the situation.
Right, and that is so true. The filters I do have, they don't get used very often, except my moon filter and maybe my red one when I'm looking at the moon from Francis Park. I don't use the O3, and I've got a Sky Glow filter. Cook was earlier in the earlier session. He mentioned a UHC filter, and I don't have that one, but I do have a Sky Glow filter, and I thought it would work in the city. And you're right, all it does is just make dim objects dimmer. So I don't use them much.
I mean, the principle they work on is that they dim wavelengths you don't want or don't need more than the wavelengths that you're trying to see. I
see.
I didn't explain it very well. The nebula, you're trying to see select wavelengths in the nebula, and the filter passes those wavelengths through much more readily than other wavelengths of light. So the contrast between the desired wavelengths and the ones you don't want increases tremendously. But you still got to have enough light to begin with. You got to have enough aperture.
Well, that makes sense. And the Sky Glow filter I have is 15 years old or 14, and it's probably predates the type of lighting that's used in the city now. And I don't think it's cutting out the right wavelengths anymore. It's like sodium vapor versus LED. A lot of the city now, they're using LED street lights.
Yeah.
And I think the Sky Glow filter I have actually cuts out sodium vapor, and there isn't any. So all it does is make everything dimmer. Hey, I got company. I don't know if you can see him. Here. I got company.
I see him.
Here, come on, Cat, get out of the way. I'm busy here. Well, this is kind of a sad day, you guys. This was to be our inaugural Danville night for 2020, the first new moon Saturday in April. And it's kind of a big deal. I mean, it's a night I'd stay up later than usual and probably even go out to Denny's or something afterwards. And it just isn't happening this year. This year's been really a disappointment in a lot of ways. But we're making do, right? Okay, how about M108 in Ursa Major? It's going to be on the other side of the sky. We're going to swing our scope all the way around to the north. And I do want to see the star clusters in Auriga before Auriga sets. You know what? Just like I would do at Danville. Heck with Ursa Major. It's going to be up for a while. Let's head for Auriga before it's gone for the year and look at the 3 clusters in Auriga. Let's start with 37 through the finder scope. Here we go, M37. 37, 38, and 36 are 3 of my favorites. They're all about the same distance from Earth. If I remember right, they're all about 4,000 light years away, and they're all about the same size. They're about 1/4 of a degree across, so they show up really well in a low to medium power eyepiece. So let's put a low power eyepiece on M37. Give me a little bit less than a degree, and you can see that 37 really shows up nicely at that power. For me, this would be a 26 to 32 millimeter eyepiece. Nudge the scope here to keep it in view. And all three of the clusters in Auriga are about the same size and distance and brightness, but they're different in terms of density and variation of brightness. Like, for example, 37 has bright stars in it and medium brightness stars and faint stars, whereas I think 38 is more evenly distributed with all like medium brightness stars, if I remember right. And these three clusters actually show up pretty well from the suburbs. So you don't have to be out at Danville or Tamalco or one of our dark sites. It shows up pretty well from the county or the suburbs. Not too well from the city or from the science center though. Okay, back to our finder scope here. And we can just move our scope over to 36. And this is a pretty area of the sky too. It's got a lot of background Milky Way stars. It's just fun to just scan with your finder scope or binoculars in this part of the sky. Especially, you want to hit it now in early spring before Auriga sets for the year. It's more of a winter constellation, but you can catch it in April. And by May, it's too low. So as you can see, with a medium power eyepiece, about 1/2 degree of a field here. 36 is about the same size. It's listed here at 10 arc minutes, whereas M37 was 15 arc minutes. So they're similar in diameter. They're both 6 magnitude clusters. So they are naked eye visible. If you're out at Danville or Tamalco and you look in the direction of Auriga, you can actually barely make out where they are. Having them in a row makes it easier for them to stand out when you're kind of looking naked eye. Just wear your glasses. You won't really see them without. You need sharp vision for it. Okay, so back out to the finder, and then 38 is this way. So they're all, you can see they're all in a line here, 37, 36, 38, just like that. Let's put 38 in our Telrad and put our low power eyepiece in. And again, this one's 1/4 degree across. Shows up really good in a wide angle low power eyepiece, like a 26 millimeter or a 20 millimeter wide angle, or even a semi-wide angle like one of Teleview's D-Los or D-Light eyepieces. It doesn't have to be the 100 degree ethos or one of those, but anything with a 70 degree apparent field of view, you get a really nice view of the background stars around it. It makes it really for a real treat. Again, about 4,000 light years from Earth. Okay, let's go back out to naked eye view. Hey Jim, did you finish with McDonald Observatory? Did Stephen finish? Yeah. Okay,
Yeah,
I had to bail early to start this session.
Yeah.
Yeah, that was great. I really liked that view of the Needle Galaxy.
Did you get to see M87?
Yeah, just that's about when I had to leave, but with the jet coming out.
Yeah, no kidding, right?
Yeah, and you know what? I wanted to ask you, can you see that with an amateur size scope? Can you see the jet coming out of M87?
I don't know. That was imaged through a 16-inch. So we will have that capability when we get our observatory scope up. I don't know if it's dark enough at Jefferson College to be able to do that, but I just downloaded SharpCap so we can use the software that he was using to do those live images.
He commented that a smaller scope could see that.
Okay.
About an 8-inch.
I brought it up here in the software, and it's not simulating the jet, but this is a low power eyepiece, just under a degree of a field. And I've looked at it before, but I never looked for the jet. So I don't know if I can see it or not. I'll have to try it again.
Try zooming in on it.
Okay, there's a medium power eyepiece, about 130 power. Here's a high
Sky
power.
Safari doesn't show the jet in the software either, but in the description for the object, it's got an image and it shows the jet.
Oh, cool. Yeah, Jim, that should be one of the first things we try with the Jefferson College scope.
Fun, right?
Hey, what's going on with it? Are we delayed because of the virus?
Yeah, a little bit. You know, they are in the process of trying to get the bid for the construction through. I don't know what the status would be of actually doing the construction, but I think it's on delay at the moment.
Okay, so we're still waiting.
We'll probably have another meeting this month sometime to check on that.
Okay, 'cause I'm still wanting to roll up my sleeves and help move with the move. I'm looking forward to that.
Yeah, that'll be fun.
Okay, back to naked eye view. I kind of detoured over here to see M87. And M87 is one of the Virgo cluster galaxies. Is that right?
Yeah. Yeah, it's actually labeled here as Virgo A.
Really? Okay. I see it's got an NGC number. I didn't know it was Virgo A. That's cool. Wow.
Yeah, it's 4486 on NGC.
Yeah, M87 was actually mentioned in the movie Contact. That was what they were. That's what they were studying when they were threatened to be shut down because their funding was being cut off.
Yeah.
And we're studying M87. I didn't know what it meant when I saw the movie.
On-the-go families, in-the-know grandparents, and busy students. But did you know we also have ways to manage your energy? Paperless billing, outage notifications, pick a due date, auto pay, and so much more. So no matter who you are or how you use your energy, there's an option that's right for you. Learn more at aaron.com/options. It can happen to anyone.
Okay, I'm heading back to M108. That's where I was going before I interrupted myself with the clusters in Auriga.
Little things get better. It's a prayer answered by God's love in the Society of Saint Vincent de Paul. People right here in St. Louis who bring.
I'm going to use my go-to since I have it. I really need to memorize where these are. Okay, through the finder scope, M108 is a spiral. It looks like almost an edge-on spiral galaxy. It's listed at magnitude 10.7. So through the finder, you may see a very faint smudge. And when you do, throw in an eyepiece and see if you can make it out. At low power, it has a size of about 8 arc minutes across. So this would look really good with medium power, about 130 in my case. So let's simulate that. There we go. So this would be with my 15 millimeter eyepiece in an 8-inch f10 Schmidt-Cassegrain. And that will vary depending on the focal length of your telescope. But what you want to do is have, when you're looking at galaxies, you want to be at the darkest place you can be, and you want it to fill up about maybe a fourth of your field of view. if you zoom in on it too much, if you use too high a power, then it just begins to kind of fade out. So you want some dark sky around it so you can kind of see where it ends. If you put too much power on it, you can't really tell where the galaxy ends. And you can give your eye a chance to dark adapt a little more and spend some time with these faint galaxies. So I would go, here's just about a half a degree of field. Like I said, medium power works pretty well in most of the Messier galaxies. Hey, Jeff, I can see your scope there.
Yes, it's off the other mount. I wanted to, I couldn't tell you what the focal length was off the top of my head. I wanted to do some math.
Is that it looks like a Celestron orange tube.
Yeah, that's a 6 SE. It's off the SE mount because the SE mount is roasted right now. I did something to the MC board. I'm waiting for Celestron to get back to me.
I know John Beery has a Celestron 6-inch, and I can't remember. I don't think it's a Schmidt-Cassegrain. Is it a Schmidt-Newtonian? I'm trying to. It's a reflector. John, you brought it to Danville or to Magnolia Hollow, I know, and it's on an equatorial mount. But I'm trying to remember what the optics are. Is it a Schmidt-Newtonian?
It's a Newtonian, basically. It's a reflector.
Really?
Celestron played around with the term Celestron 6 over a wide variety of optical systems. They applied the name to what I've got. They applied it to a Schmidt-Cassegrain, and they weren't very consistent in their marketing in the early years.
Oh, okay, so I was just wondering if it was the same as the one Jeff has. I don't think so. It looks like Jeff's is a Schmidt.
Yeah, this is an SCT.
Yeah, I think it's a 1500 millimeter focal length.
Yeah,
Mine's a 6.
That's why I swung it around to look at it.
Mine's a 6-inch Newtonian.
Now, Jeff, you can't bring a scope to these things without getting bombarded with a bunch of questions.
That's okay. You can ask.
We want to hear all about it, just so you know. That's part of the fun, though.
Universal health care doesn't sound too crazy now, does it?
Okay, all right. Zoom's going to cut me off here. So is there anything else you guys want to look at or do before we quit?
Actually, I think I'm done for the evening.
All right, well.
So it's good session.
Oh yeah, good presentation.
Yeah,
Thank you, guys. Good to see all of you. And you guys stay safe, all right? And I'll post another one. We're going to do a Francis Park one, too, on April 29th. So if you can, I'll be looking for you there.
Well, eventually
Okay.
we'll be able to do this for real.
Thanks, Bill.
You're
Thanks,
welcome.
Bill.
Thanks,
Appreciate
guys.
it, Bill.
See you guys.
Bye-bye.
Thank you.